Atomic structure. At the beginning of the 20th century, the structure of the atom was something of a mystery. In 1904, Thomson came up with the idea of the plum pudding model of the atom. This recognised that the atom was a singular entity, but nothing was known about the structure. The idea was that the atom consisted of an amorphous positive charge with embedded electrons. Rutherford conducted his famous experiment in which he fired alpha particles at a sheet of gold leaf and was very surprised when some of the alpha particles bounced back. Rutherford's explanation of this experiment was that the atom consisted of small dense nuclei and were mainly empty space with the electrons. The Rutherford experiment says nothing about the electrons. In 1913, one of Rutherford's students, Niels Bohr, came up with the Bohr model of the atom. And this had electrons in shells, and these shells were quantized. They were of definite energy levels, and the idea was that the electrons could jump between shells and absorb and emit energy of energies which were equal to the energy differences between the shells. Right, at this point the science bifurcated. On the physics side, Niels Bohr looked at the atoms, gas phase atoms, and he examined properties such as the first ionization energies. And he noticed that the first ionization energies, although they generally increase across a period, they actually go in a series of jumps. They go 1, 2, 1, 2, 3, 1, 2, 3. Bohr interpreted this as the electrons existing in shells and subshells, which he named 1s, 2s, 2p, 3s, 3p, 4s, 3d, etc. In 1924, de Broglie took the idea that light can be considered as consisting of waves or particles and applied the idea to the electron. He decided that the electron could also be considered as a wave. 1926, Edwin Schrödinger took the idea of the wave-like electron and constructed a mathematical differential equation for the wave-like electron resonating about the point positive charge of the nucleus. Remarkably, solutions to the Schrödinger wave equation equate to the quantum numbers 1s, 2s, 2p, 3s, etc., devised by Bohr in the preceding years. An alternative interpretation took place. In the years 1916 to 1923, G.N. Lewis of the University of California in Berkeley had led a very active research group. Indeed, Lewis is regarded as being the greatest chemist never to receive the Nobel Prize. Lewis's group took the new ideas of atomic structure that were emerging and applied them to the chemical problems, particularly chemical bonding. From this came the Lewis octet model, the idea that atoms like to have a filled octet with 8 electrons in their outer or valence shell. This is used in the idea of the covalent bond and the ionic bond. And indeed, school students the world over learn about this using dot and cross diagrams. Lewis theory can be greatly extended to the ideas of the outer electrons containing 2, 8, 8, 18, 18 electrons, the 2 electron chemical bonds, lone pairs of electrons, electron accountancy, reaction mechanisms, Lewis acids, Lewis bases, electrophiles, nucleophiles, radicals, curly arrows, fishhook arrows, valence shell electron pair repulsion theory, etc., etc. Indeed, most chemistry is taught in terms of Lewis theory, most of the time. This leads to the rather strange situation where we have two very, very different ways of thinking about chemistry, structure, bonding and reactivity. On one hand, we have molecular orbital theory, which is accurate and precise, but is computationally intensive. On the other hand, we have Lewis theory and the idea of the two-electron chemical bond, which is very simple to understand and is learnt by students the world over. Part of the problem is that textbooks will flip between the two views, and they will talk about the pi bond and overlapping p orbitals, and the next moment they will talk about oxygen having a lone pair of electrons. These are two entirely different views, one involving the wave-like electron, the other using the particle-like electron. This is just something that students of chemistry have to get used to.